Today we're going to talk about average value of a function. Before we start that, I just want to quickly point out this theorem, the second fundamental theorem of calculus. Normally we would go over this and do a bunch of examples on it, but we're going to skip it this year. So first of all, it's not really the second fundamental theorem of calculus. It's still the fundamental theorem of calculus, just a different way to look at it. Basically, it unites integration and differentiation. That's why it's so fundamental to calculus. It almost says that it does say that the derivative and integral are inverse functions. So basically an integral will undo a derivative and vice versa. And you can see that here. We're taking the integral of this function f from some constant a to x. If you were to take the derivative of that function, it basically undoes the integral, and you're just left with f of x. We'll stop there with that and go right on to the average value of a function, which is a little bit more concrete, something that we can apply. This says that if you have any function on any interval, the average value of the function over the interval is 1 over b minus a times the integral of that function from a to b. Basically, the regular integral, just integrate the function on the interval and divide by the length of the interval. That's all that's saying. So we're going to now, I'll show you that. We're going to use the sine function because the sine function we know a bit about, and we can probably predict the average value of the sine function on certain intervals. So this first question is, what's the average value of the sine function from 0 to 2 pi? So the first thing I want you to realize is, remember average value. Value is the y value. So sine function starts out at 0 at a value of 0. And then it goes up to 0.5, 0.7, 0.8, 0.9 to 1. Back down to 0.7, 0.6, 0.5, 0.2 to 0. And then the value goes negative 0.1, negative 0.2, negative 0.3, all the way up to negative 1. Then back down, negative 0.6, negative 0.2, all the way back down to 0. So the average value would be averaging all of these values together. That would be impossible to do without calculus. There's an infinite number of values. So let's see what we get. But before we see what we get, I want you to, and this is serious, think about it. Think to yourself now, what is the average value of the sine function from here to here? Okay, now yell out your answer so I can hear it. Oh, good. I heard some good answers there. Let's do it. So the calculus would say, if you want the average value of this sine function from 0 to 2 pi, you take a would be 0, b would be 2 pi. You do 1 over b minus a, 1 over b minus a, times the integral from a to b of sine of x. So 2 pi minus 0 is 2 pi. The integral of sine of x is negative cosine of x. And we're going to evaluate that from 0 to 2 pi. Negative is a constant, so I can just go negative 1 over 2 pi times the cosine of plug in 2 pi minus the cosine of plug in 0. Now the cosine of 0 is 1, and the cosine of 2 pi is the same spot. This is 0 and 2 pi, so it's still 1. So this is negative 1 over 2 pi times 1 minus 1, which is 0. And that's what you yelled out, right? You yelled out 0 because all these values, if you take the average, the positive and negative values are going to cancel each other out, and you're going to be left with 0. So hopefully that actually makes that average value make more sense. Driving home the point now, what if I try to figure out the average value of the sine function from 0 to pi? This is going to be quicker because we're going to do it with the calculator. So stick with me here, please. So now we're looking at the average value of sine from here to here. So 0.5, 0.6, 1, 0.9, 0.8, 0.7, 0.6, 0.5, 0. So now to think what the average value would be, it's not going to be 0 because all these values we're averaging together are all positive. And just because it's kind of bowed outwards, I would say the average value would be somewhere around here. If this were, say, if this were a straight graph, it looked like this, then I would say the average value is right in the middle. But since we're bowing out, it looks like that would increase the average value a little bit more. I hope that made sense. If it didn't, well, that's okay. We'll just ask calculus, what is the actual average value? So I'm going to take out my calculator here and type this in. So the average value, now A is 0, B is pi instead of 2 pi. So it's 1 over B minus A times the integral of sine from 0 to pi. So a trick on the calculator, you know how you can factor out a constant from an integral? Well, you can factor the constant in as well. And I'd rather have this constant in other words, the 1 over pi. When I do it on my calculator, I'd rather have it in because the calculator is now going to do all the work. So all I have to do is type in 1 over pi. Let me go over. 1 over pi times the sine of x. Graph it, and now integrate it from 0 to pi. So I have to wait till it's done graphing, otherwise you get that frozen screen. Second, calc 7, lower limit is 0, upper limit is pi. Hit enter, and the value of this integral is 0.6366. Which is about right here, 246-ish. So the average value is right around this area. That makes sense. So that's average value. The next video we'll do a couple of examples, and then you can practice those tonight.